So number 6 says find the secant, cosecant, and cotangent of a 135-degree angle. So we already know sine of the angle acts like y, and cosine of the angle acts like x, right? We already know that. We also know that tangent is sine over cosine. So if I'm using x and y to represent them, sine over cosine will be y over x. Right? So these three we know how to do already. We did these on Thursday, this today. All right? But once we've established these relationships, the other three trig functions, secant, cosecant, cotangent, are the reciprocal functions of these three. That's not the order I like. I like to put cosecant first and secant second. So I'm going to say cosecant of the angle is equal to something, secant of the angle equals something, cotangent of the angle equals something. Okay. The order of these is really easy to remember. You just remember to put cosecant first. Always put cosecant first. Always sine, cosine, tangent, just SOHCAHTOA order right here. Always put cosecant first. Look at cosecant's abbreviation. CSC, CSC. Remember to cosecant first. You got that order every time there. All right? So just make sure you get those in the proper order because, again, you're reciprocating each individual function. It matters what these functions are. So if sine is y, the reciprocal is 1 over y. If cosine's x, the reciprocal is 1 over x. If tangent's y over x, cotangent reciprocal x over y. So I can still relate those to cosine and sine. Again, cosine acts like x, sine acts like y. So if I've got a 135-degree angle, so this time we're in degrees, not radians. 0 degrees starts here, and we go 90 degrees each time we get to a new section, right? This is 90, this is 180, this is 270, this is 360. Again, that's our friendly region from 0 to 360 we want to deal with. So if 0 is less than or equal to the angle we want to work with is less than or equal to 360, does this angle fit in that interval? Is 135 in between 0 and 360?
Yes.
Sure is, right? So we're ready to go immediately. Which two numbers on this picture is 135 between? 180 and 90, right? Right, so 135. So if I go to 90, how far past 90 do I go to get 135? How big is this angle here?
45.
That's 45. So altogether, this is 135. The angle I want to know, though, is the angle that comes down to the x-axis. I always want to draw my vertical line directly to the x-axis, and this is the angle I want to care about. That's my reference angle, alpha. Remember that this segment, this horizontal segment, represents cosine of alpha. This vertical segment represents sine of alpha. The radius is always 1 because we're in a unit circle. Okay. So, if that's 135, how big is alpha?
45.
How do you know 45, Daniel?
It's 180 minus 135.
180 degrees here. We stopped at 135, so there's 45 left over, right? So these two angles add up to 180. So alpha plus 135 is equal to 180. Therefore, alpha must be 45 degrees. Again, just looking at the picture. That angle plus that angle makes a straight line 180. All right, so if I'm drawing my reference triangle here, here's my reference triangle. This is the origin right here. This angle right here, my reference angle we've established is 45 degrees. We've got a right angle here, so this must also be 45 degrees. The hypotenuse is 1. How long are the legs? This thing we've committed to our memory?
2 over 2.
Square root of 2 over 2, right? So if you want the whole, like using the 45, 45, 90 relationships to find them, but just to save us time and energy, if you just remember square root of 2 over 2 for these, and for the 36 90, it's 1/2 and square root of 3 over 2. 1/2 opposite 30, square root of 3 over 2 opposite 60. Okay. For cosine, which direction am I going from the origin? I'm starting here. To get to this point, which direction am I going for cosine? Going left. So cosine should be negative. And I'm going up, so sine should be positive, right? So just like that, we've established the sine and cosine of 45 degrees or I should say 135 degrees. So I know the sine of 135 degrees is positive square root of 2 over 2. The cosine of 135 degrees is negative square root of 2 over 2. And I'm tasked to find cosecant, secant, and cotangent. Right? Would everybody agree that tangent of 135 degrees is just be this divided by that? Could somebody real quick take a look at this? Square root of 2 over 2 divided by negative square root of 2 over 2. What sign should that be? Positive square root of 2 over 2 divided by negative square root of 2 over 2.
Negative.
Negative. When you divide square root of 2 over 2 by the square root of 2 over 2, what do you get? 1 y. Why? Because when you divide a number by itself, no matter how ugly the number is, you get 1, right? 7 divided by 7 is 1, 5 divided by 5 is 1, the square root of 2 over 2 divided by the square root of 2 over 2 is 1. Hippopotamus divided by hippopotamus is 1. It doesn't matter what it is. If you divide something by itself, you get 1. That's divided by itself. Opposite signs made the negative, but the same number divided by itself makes 1. So, tangent's negative 1. Okay? Reciprocal functions, cosecant, secant, and cotangent. Let me extend my page here so I have room to write my answers. Cosecant of 135 equals something. Secant of 135 equals something. And cotangent of 135 equals something. Cosecant's reciprocal signs. If I flip that over, I'm going to get 2 over the square root of 2. Is that a good form for a final answer? How do I fix it? Multiply by square root of 2 over 2. So top times the square root of 2, bottom times the square root of 2. That gets me 2 times the square root of 2 over 2. And the 2's outside the radical cancel, so we're going to get positive square root of 2. So cosecant of 135 is positive the square root of 2. Notice that secant of 135 is just going to be this flipped over, which will be negative 2 over the square root of 2. Can everybody see that's the exact same structure, just different sign? So if that structure makes positive square root of 2, this structure should make negative square root of 2. So again, if you recognize similar structures, you're allowed to use that fact to shorten the amount of work you have to do. What's the reciprocal of negative 1?
Negative 1 over 0. Oh.
Negative 1 is negative 1 over 1. If you flip it over, you get 1 over negative 1, which equals negative 1, right? So 1 over 1, 1 over 1, they flip it, right? It's the same. So tangent's negative 1, cotangent's negative 1. Find secant, cosecant, cotangent 135. There you go. And use the sine, cosine, and tangent to find the secant, cosecant, cotangent. Every single problem of this variety, you're finding sine and cosine every single time. Okay, so you're practicing what we did last week every single time, and then using those facts, sine and cosine, to build tangent, cosecant, secant, or cotangent. All right? Use sine and cosine to find the other 4 every time.